So because I demonstrated in the last video that drawing things in 3 dimensions can be rather challenging, one of the ways that we help envision what's going on is through the use of traces. So traces are a 2-dimensional cross-section of whatever 3-dimensional thing you're looking at. Now the way that we arrive at a trace is we set one of your variables equal to a constant. What you're doing is creating a cross-section that is parallel to one of the 3 coordinate planes. For example, if you were to set the z variable equal to a constant, setting z equal to a constant would give you something that is parallel to the xy plane. We refer to this as an xy trace. If you set y equal to a constant, so essentially straight up and down like that, you'd be creating something that is parallel to the xz plane. So we refer to this as an xz trace. Whereas if we were to set x equal to a constant, so slicing sort of up and down like this, you'd get something that is parallel to the yz plane. So we refer to that as a yz trace. Now, for an example of this, let's consider that cylinder that we just had in the previous video. X squared plus y squared is equal to 4. The xy trace, we would set the z variable equal to a constant and consider what that thing looks like in the xy plane. But there is no z variable. As a result, if I were to set z equal to a constant, I would just get that nice circular cross-section that we're used to seeing from that cylinder. Now if I were to consider the xz trace, that would be set y equal to a constant. So x squared plus some constant squared is equal to 4, or by solving for x, we would get x squared is equal to 4 minus a constant squared, or x is equal to plus or minus the square root of 4 minus k squared. Now that's x is equal to a positive constant and x is equal to a negative constant. Now when you have x equals a constant in the xz plane, as it were, the positive constant will be over on the positive side and the negative constant will be on the negative side. These two would essentially be the sides or the lateral part of the cylinder that we referred to just a moment ago. So I'm going to show you the previous page. That would be like the lines that are going straight up and down on either side. Finally, if we were to consider a yz trace, something very similar would happen in terms of the algebra. We set x equal to a constant, and we'll go ahead and solve for y. In fact, the algebra works the same way. Subtract the k squared and take the square root of both sides. So in terms of a yz trace, we're going to make y the horizontal axis and z the vertical axis. This would be, once again, a pair of lines going straight up and down. Now imagine you do have, say, a can of Pepsi lying around. If you were to slice that can of Pepsi directly across the middle of it, then this would be the cross-section that you see. However, if you were to slice it, say, from top to bottom, the 2 edges of the can would be referring to these 2 vertical lines here. And again, when viewed from the side, once again, it looks like a pair of straight up and down lines. So putting these 2 things in terms of this context and these 2 things in terms of this context coming straight up and down, hopefully this allows you to envision what's going on a little more efficiently. Now when we get to the next style of surface, however, every single cross-section is going to be some sort of conic section. So let's do a quick review of conic sections.